Chips are everywhere, and since the pandemic's early stages last year, they have been in limited supply. Due to this, purchasing everything from PS5s to vehicles has been challenging. One business produces 24% of the world's chips and over 90% of the most technologically sophisticated ones, the tiniest, quickest processors utilized in today's iPhones, supercomputers, and automobile artificial intelligence. We even have equipment that was delivered on the most recent Mars launch and is capturing photos of Mars. TSMC, often known as the Taiwan Semiconductor Manufacturing Company, is not a well-known brand. However, it is covertly producing semiconductors for each and every new iPhone, American fighter planes, the most advanced processors, etc. But now, it's spending $100 billion over 3 years to expand production amidst the scarcity. Over 12 million wafers are produced annually due to all we do. However, the world's heavy dependence on TSMC may also make the supply of chips vulnerable to natural disasters like earthquakes and droughts, as well as geopolitical conflicts with China. It's become nearly a monopoly at the sharp end, and all of those manufacturing activities are mostly apportioned out of Taiwan, Hsinchu. That has become a subject of significant value for the United States. Perhaps not just in the United States, but even in the Western world. This factory has a total floor area of around 2.3 million square feet, and advanced silicon was created in the United States. However, Asia, where currently 75% of chip fabrication takes place, has been gaining market share from it for decades. With a $12 billion manufacturing factory or fab in the heart of the Arizona desert, TSMC is now taking the most cutting-edge chip making back to the United States. It's supposed to be when it gets launched to manufacturing in 2024, the most sophisticated technology created in the United States. Investors were dubious when Morris Chang initially brought forth the proposal for TSMC in the middle of the 1980s. Chinese-born, Harvard, MIT, and Stanford-trained, Chang left Texas Instruments after 25 years and relocated to Taiwan. There, the government urged him to develop a Taiwanese semiconductor business that would become a worldwide leader. His idea focused entirely on production, what's called now a pure-play foundry. You perform one thing very well when you are solely focused on it. The chief executive of TSMC in the US is Rick Cassidy. He has worked for the business for 23 years. The chunk they threw out is just foundry. That is what they also do. And they concentrated all of our efforts on doing that one task. Chang placed a large wager on a need that did not exist in the 1980s. Manufacturers like Intel and Texas Instruments took pleasure in creating their own chips when he launched TSMC in 1987. When Morris started looking for investment, he went to several renowned corporations, and as chips grew more complicated, manufacturing them became a massive endeavor. Today, it requires at least 2 years and $10 billion to establish a fab. Even the largest chip manufacturers such as Intel, NVIDIA, Broadcom, Qualcomm, and AMD find it challenging to stay up with the most cutting-edge technology. For instance, Intel continues to develop and manufacture its own CPUs, but in recent years, it has lagged behind Samsung and TSMC, and it even depended on TSMC to produce some of its chips. Therefore, with the development of TSMC, skilled designers were no longer required just to have billions of dollars in a fab behind them. Now, each significant phase of chip making is generally handled by a particular business. Others, like ARM and MIPS, concentrate on IP and architecture, giving the essential building blocks to construct processors. Then there is electronic design automation, or EDA, where firms like Cadence and Synopsys write software for designing semiconductors. The $180 million intense ultraviolet light devices needed to etch patterns onto the most cutting-edge semiconductors are produced by just one business, ASML. Of course, the enormously successful fabless firms also create the chips. Consider companies like Apple, Qualcomm, NVIDIA, and a host of others. As these fantastic businesses took up, TSMC found itself producing an increasing number of the nation's chips. And as a result, TSMC has been able to not only catch up with, but also, in my opinion, transcend Intel to become the best manufacturing technology ever created. TSMC is also to thank for making one of several top 10 most valuable businesses in the world according to market value. In 1994, TSMC debuted on the Taiwan Stock Exchange. It was the first Taiwanese firm to list on the New York Stock Exchange in 1997. It had wrapped up to roughly 20 other businesses producing the newest chips by the 2000s. More and more manufacturers lagged behind as technology developed, and currently, only TSMC and Samsung are capable of making the most sophisticated 5-nanometer circuits. As it moved away from dependency on Samsung, a direct rival in mobile phones, Apple started relying on TSMC to build its A-series semiconductors for the iPhone in 2013. There's a TSMC chip in every iPhone just on the market. Apple has moved away from Intel and depended on TSMC to produce processors inside most of its products as they continue to exist in the background. As a result, Apple receives all the praise whenever a new phone is being released. Experts let their items do the talking. Their success brings about all the business they could possibly aspire for. Why didn't TSMC invite American media in with its sites earlier? Does IP have a role in secrecy? Yes, since the preservation of intellectual property is crucial for this sector, not just for TSMC but for the other firms involved. Chang stepped down as chairman of TSMC in 2018 at the age of 86. His unconventional pure-play foundry concept is still profitable. With a new fabrication facility set to open in Taiwan the following year, TSMC and Samsung are vying to produce the first 3-nanometer circuits. Intel expects to do so by 2025. Besides having extremely advanced 3 and 5-nanometer circuits, TSMC also makes far bigger chips for anything from automobiles to coffee machines. Let's look at how chips are created to comprehend the many types of chips and why nanometers are essential. Circular wafers of silicon, an abundant material present in rocks and sand, are produced after being cleaned, heated, and then cut into pieces. These wafers serve as the grid-like building blocks for the chips. There may be hundreds of microscopic layers of transistors and electrical circuits on each chip on the wafer, which together determine the chip's functionality. Lithography, which uses incredibly accurate laser beams, is used to print the tiny circuits on each layer. Increased processing power could be satisfied in a given size with less energy required if the transistor gate width is smaller, for example, 5 nanometers or 3 nanometers. The tiniest transistors exist, more than 10,000 times thinner than human hair. The majority of the chips are definitely more significant than my thumbnail in size. There might be more than 50 billion transistors there, and they all need to function. These components, including CPUs, GPUs, and IPUs, will be employed in a variety of applications. Smartphones will take advantage of them. Most domestic appliances, such as a TV remote control and an electric toothbrush, require larger chips. Typically, 28 to 40 nanometer chips are used in automobiles, and the scarcity affects all kinds of chips. Automakers, including GM and Toyota, have halted production at specific sites. Additionally, Apple is lowering its projections for iPhone 13 manufacturing in 2021 as demand for the 13 Pro Max is more than a month behind schedule. 5-nanometer circuits cannot currently be produced in any American fab, but TSMC is working to change that. These consumer goods have a large client base thanks to the F-35 Strike Fighter. In the United States, they serve more than 500 businesses. As a result, specialists were aware that they would eventually want to be in the United States. Chris Camacho of the Greater Phoenix Economic Council visited TSMC's fabs in Taiwan during the 5 years he spent helping negotiate the agreement that brought the project to Arizona. The robots, the automation, the mechanization are happening before your eyes, and you'll see how these things are not only so capital demanding, but their product is also so significant. The enormous 5-nanometer fab south of Phoenix, which TSMC is currently developing, will produce 20,000 wafers monthly beginning in 2024. High-end CPUs, iPhones, and many other products will use the wafer's chips. Arizona project leader Tony Chen has overseen 17 other fab-building projects in his 23 years with TSMC. The 5-nanometer fab is the target for this project. It is a replica made in a factory here in Taiwan. Nearby, Intel is investing $20 billion in the construction of 2 new fabs. Several of the largest machinery in the world has come to Arizona thanks to these enormous structures formerly used to produce tiny chips. This is the biggest crane that Manitowoc builds. There are just 2 of them altogether in existence, and the crane weighs 2,300 tons. The contractors have transported roughly 3,731,000 cubic yards of dirt since they began. About 260 million gallons of water have also been used. It is true that creating a fab and producing chips requires a tremendous amount of water, which is difficult to come by in the midst of the desert. Groundwater is Arizona's primary water source, but deep wells at vast farms are soaking up groundwater quicker than naturally replenishing. They do require roughly 4.7 million gallons per day of water to sustain the production. TSMC is no random person with water difficulties. According to TSMC, Taiwan's worst drought in 56 years has not hindered the output. Up to 90% of the waters used at the fab in Arizona will be recycled, according to TSMC. When reverse osmosis and other technological solutions are used, the water will be pumped back into the aquifer in collaboration with the city of Phoenix. The current experts are all in Asia, which presents another difficulty in manufacturing the most sophisticated chips domestically. TSM's top engineers right here in Taiwan. They'll probably remain in Taiwan. Taiwan will conduct the most innovative research and development. Roxana Vega, a recruiter, claims that TSMC is sending some of its best specialists from Taiwan to resolve this. In the fabs, as you see, they are regarded as subject matter experts for what they do. Therefore, will only be a temporary position for 2 to 3 years. TSMC has already dispatched about 300 new US recruits to Taiwan for 12 to 18 months to come up to speed. And having the chance to study in the 5nm gigafab in Taiwan will give them an understanding of just how large and advanced the equipment will be in Arizona. When it comes to designing analog semiconductors, Taiwan is not particularly good. And by going to the United States, they would be able to leverage a considerably greater quantity of analog designers. This diversity is a fundamental motivation for TSMC to take innovative strategies to the US. Then, there's closeness to its major, fabless clients situated in the US like Apple, Nvidia, and Qualcomm. If you want greater capacity, you have to construct more fabs. And it is one of the factors they are relocating to the United States. The American government and the clients want to be in the country. Still, American businesses make up more than 60% of their clientele. Since TSMC has 12 fabs, nearly all of them throughout Taiwan and China, some of these businesses, like Apple, have made it known that they prefer their stores to be local. They generate over 54% of all foundry sales worldwide. Furthermore, due to the world's dependence on TSMC so heavily, it is susceptible to possible slowdowns brought on by earthquakes, the ongoing dryness in Taiwan, or geopolitical unrest involving the United States, China, and Taiwan. The silicon shield of Taiwan is how some people refer to TSMC. The silicon barrier from TSMC is very, very crucial, and experts believe that individuals depend on them. The media gives a pretty dismal image of this scenario, but because of this concept, the semiconductor shield, I'm actually a lot more upbeat. Right now, China needs them for its cutting-edge manufacturing. The administration pushed hard to persuade TSMC to move its technology here, since the United States depends significantly on chips produced in Taiwan. Conflict on a geopolitical level won't be a concern for us. Another significant pandemic won't be a concern for us. Experts will have this sort of industrial capacity on US soil. Only 13% of the world's semiconductors are now produced in the United States. That is indeed down from about 37% in the year 1990. They were most likely entirely at Bell Labs and in the early years of Silicon Valley. State and federal authorities are keen to persuade TSMC to return cutting-edge silicon to the nation where it initially gained popularity. The state of Arizona provides a variety of initiatives like the Qualified Facility Tax Credit and the Quality Jobs Tax Credit. This is actually an incentive to assist cut the cost of operations. A $200 million infrastructural plan put together by the city of Phoenix also aids TSMC in getting access to water and other necessary infrastructure. For semiconductor manufacturers like TSMC to locate their operations in the United States, the Biden administration has offered $52 billion in incentives. The infrastructure is known as the CHIPS legislation. So let's face it, we must create modern infrastructure, not fix the problem from yesterday. And initiatives such as the CHIPS Act were extremely necessary for the nation to succeed, both in terms of competing internationally and luring these kinds of businesses to set up shop in the United States. If not, we will have to import chips for the rest of our lives. We have gradually lost ground in the industrial sector over the past 20, 30, or 40 years, mainly as we have observed cost reductions in other nations, and it's anywhere between 20 and 25%. It is less expensive for American companies to manufacture chips elsewhere. TSMC's Riz Cassidy was engaged in conversations that culminated in the CHIPS Act. The only thing we really want is to level the playing field. so that chip production in the United States doesn't cost more than it does elsewhere. According to industry projections, the US government could build 19 additional fabs in the country over the course of the next 10 years with a $50 billion investment, more than tripling domestic chip production capacity. Similar investments are being made all around the world while the scarcity persists. By 2024, 72 new fabs or significant expansions are expected to open, 10 of which will be in the North and South America, according to industry group SEMI. In the upcoming 10 years, Korea will contribute $450 billion. The EU has declared investments worth almost $150 billion. And based on that, we anticipate that by the latter of the following year, we might begin seeing a few relief on the chip scarcity. But until then, TSMC is increasing chip costs by up to 20%, which could raise the price of consumer gadgets as desire continues to climb. If it was required, TSMC was always able to charge more, and the majority of their clients are aware that there's a solid reason, so they are prepared to pay for it. The 1,100-acre Arizona site has the opportunity for a second stage and more, so TSMC will undoubtedly continue investing in increasing manufacturing capacity, even in the United States. Although it will take time, we have the capacity to accomplish more there. But it goes beyond chips and foundries. The whole supply chain will be involved, and so as to its packaging firms. Businesses produce the necessary chemicals and gases for the manufacturing process. So experts see this as an example of a change in the semiconductor business in the United States. As you can see, everything is in one place by itself so that we may get into many problems. Therefore, experts believe that seeing the United States stop the reductions we've experienced over the past few decades would be a significant success. Do you have any knowledge of how these chips are produced? And where do you think these chips are among the things you have? If so, would you mind sharing? Please share your thoughts in the section below. Don't forget to like the video and subscribe to our channel, Technology Zone, while you're at it. Also, click the bell button to allow post notifications for more incredible videos.